Completing the square is a method that's used to change an equation that's in standard form into vertex form so we can read off the vertex of the equation. What we're trying to do is we're trying to change our equation into the form y equals a x minus p squared plus q. In order to do this, we're going to look at the term that has the x with it. So just the middle term with the x, the 6. And we're going to divide it in half. We're going to break it in half and we're going to get 3 and 3. To complete the square, we need to figure out what square we're going to add to our equation. And in this case, 3 times 3 is going to give us 9. So we're going to insert a plus 9 into our equation. But in order to keep the equation consistent, we're also going to have to insert a minus 9. So what this is going to look like, we've got f of x equals x squared plus 6x plus 9 minus 9 plus 5. To get the squared term in our equation, we're going to look at the trinomial we've created, which will be a perfect square trinomial, and we're going to factor it. So if you remember from grade 10, when we're factoring, we've got something times something to give us 9, and something plus something to give us 6. Now, of course, those numbers are going to be 3 times 3 is 9, and 3 plus 3 is 6. So factoring here, we've got x plus 3 times x plus 3. That's going to give us a minus 9, and then a plus 5 still on the end. Simplifying this and collecting all our like terms, we've got x plus 3 squared minus 4. Making things a little bit more difficult is if I've got a coefficient in front of my x squared like I do here. So if I've got a number in front of the x squared, I can't complete the square with that number there, so I'm going to factor it out. So if I factor out a 2, I'm going to divide this by 2 and I'm going to be left with x squared. Divide 16 by 2, I'm going to be left with 8x, and divide the 24 by 2, I'm going to be left with 12. Now I'm going to complete the square as I would have normally. So I'm going to divide my 8 by 2, and I get 4 and 4. Multiplying those together, the number I'm going to need to complete my square is 16. So I'm going to need to add a 16 and subtract a 16. My 2 is going to stay up front. My 8x is going to stay the same. I'm going to add 16, then I'm going to take 16 away, and my 12 is still going to be there. Now, just like the last example, I'm factoring out that perfect square trinomial. So I'm going to get 2x plus 4 squared. I'm going to leave square brackets around here because this is all still in brackets. Now, minus 16 plus 12 is going to give me negative 4. The problem here is, because I want this outside of my bracket in order to meet the requirements of a vertex form equation, I'm going to have to multiply it by the 2 in front. So I'm going to multiply this 2 in here. I'm going to end up with x plus 4 squared minus 8 as my final equation in vertex form. If I was asked to find the vertex, I could easily read that off my equation because the x form of the vertex is in the squared term, but remember we have to change the sign, so it becomes negative 4. The y term is the part outside the bracket, so it becomes negative 8. There is another way to do this. In this case, I've got a negative 4 that I need to factor out, but I'm only going to factor the negative 4 out of the first two terms. So I've got x squared, because negative 4x squared divided by negative 4 is just x squared. This one's going to become negative 9 over 4x. But because this would become a fraction, I'm going to leave it out front. Now I need to break apart my 9/4. If I take 9/4 and divide it by 2, I'm going to get 9/8. When I square that, 9 times 9 is 81. 8 times 8 is 64. So my new expression is going to be x squared minus 9 over 4x plus 81 over 64 minus 81 over 64, and I'm still going to leave the 2 on the outside. The next step, just like before, is simplifying my perfect square trinomial. So it's going to become, and I'm going to have square brackets out here, x minus 9/8 squared, and I still have the negative 81 over 64, and the minus 2 stays outside. Now I want to put this negative 81 over 64 and this negative 2 together. I'm going to have to multiply it by the negative 4. So negative 4 is going to be there because it's still a factor of my squared term. But when I multiply negative 81 by negative 64, I wind up with positive 81 over 16. Now I can put that together with my negative 2. If you remember from adding fractions, if I get a common denominator, negative 2 is going to be the same as negative 32 over 16, which means my final vertex form equation is going to be positive 49 over 16. So if I wanted the vertex, I would get positive 9 over 8 because the sign changes for your x term, and then positive 49 over 16. This question asked me to determine the axis of symmetry. Now the axis of symmetry is going to be the line going through the x point of your coordinate. So my axis of symmetry is just going to be x equals 9 over 8.